Okay, guys, so today we're gonna first recap what we learned last week, which is related t-test. So I'm gonna give you guys a brief review by walking through the practice, the Mu illusion practice I give you guys as a practice in last week's class. So basically, this experiment was trying to look at or to examine whether people's eyes level would make a difference in terms of, their perceived Mu's size. So basically, the researchers were comparing people's perceived Mu size when they elevate their eyes. Okay, so this is the data set they have for this condition, for this situation. And the perceived Mu size when people maintain their eyes at a horizon level. And this column represents this data set for this condition, the horizon level. So we can see that we are comparing these two data sets, and each individual provides two data points here. We are doing this related t-test. So we can just in the lecture I give you guys the example I worked with you guys is pre versus post test results. So but basically for this practice you can also view this condition as a pre-test and this condition as a post test. And basically you are comparing the data sets between this condition and this condition. Okay, so let's walk through this exercise. The first thing you want to do is you want to create a new data set, and this new data set we call it a difference data set. That is, you want to calculate the difference between this column and this column and see for each individual. Okay. And from now on, we are just gonna work on this difference, this new data set. We call it a difference data set. We don't need to bother to look at these two columns anymore. Okay, so this new data set again represents the difference between, for people's perceived Mu size between the condition of eyes elevated and eyes level. Remember the research question I gave you guys is to examine whether people perceive Mu in different size when they have their eyes elevated and when they have their eyes at the horizon level. So let me rephrase this question in a different way. So that is whether the difference we have here, the difference we obtained here, is significantly from zero or not. Okay. If let's say the difference we obtain here is significantly different from zero, that means we have significant different means between these two columns, between these two situations. So again, that means people's eyes level does matter, right? In terms of making them perceive the Mu in different size. But if this difference we obtain here is not significantly from zero, so we can say that, the difference we obtain here is just due to chance, it's an observation bias. So which means that people perceive the Mu actually in the same size when they have their eyes elevated and when they have their eyes at the horizon level. Okay. So again, back to our question, we want to see whether this new data set we created here, whether this difference data set is significantly from zero or not. And this is the D bar is kind of, we take the average of these 10 data points for this difference data set. That is the observed difference we have for these 10 people. And I also calculated the standard deviation for this new data set for you guys. That is 0.137. Okay, so we want to say, basically, let me draw here. So basically, we want to see whether this obtained difference is significantly different from zero or not. So let's work through these 4 steps or 5 steps. The first one is we want to set up our null hypothesis. I just explained it to you guys. the population's mean we are comparing with in this situation is 0 here. Okay. So our null hypothesis is we assume that this observed difference equals to 0. Okay. And this, so which means that this observed difference between these two data sets is actually an observation bias. It's just something kind of due to chance. It's not a true difference here. So that is not our null hypothesis. And the alternative hypothesis is this difference is not equal to 0. And second, we want to build sampling distribution of the mean for this new data set. Okay, again, we don't need to care about this two column here anymore. We just want to work on this new data set. So build this sampling distribution for the mean for this new hypothesis. And we know the mean for this sampling distribution is equal to the mean for this population, which is 0. We have learned it from the central limit 0. And next, I want to calculate the standard error. Okay, again, a standard error is the standard deviation for this sampling distribution of the mean. Okay, how to calculate it? We want to kind of estimate from this number and also the sample size. So we want to divide this standard deviation of our sample by the positive square root of our sample size, which is 10, and this gives us the number 0.043. And third step, I believe you guys are very familiar with it. So we want to standardize this observed difference here. We want to calculate its t-score. That is, we kind of subtract the mean of this sample distribution, which is 0, okay, from our observed difference here, which is 0.019, and divided by this standard error, that is this number. Okay, we plug this number, and this gives us the t-score for our observed difference here, which is 0.44. So what does this mean? Can we get some meaning from it? Well, we cannot get any meaning from this t-score by itself. We must have this t-table to kind of make the comparison, and then we can make meaning of this t-score. So the next step is we want to check the t-table for the critical t-value given a sample size of 10, which means we have the degree of freedom of 9, at a significance level of 0.05 with a two-tail test design. So we have, checked the t-table. And let's say we are looking at this column here and at the degree of freedom of 9, which gives us the critical t-value 2.26. So 2.26 is our critical t-value. We want to compare our obtained t-value with this critical t-value. We found that our obtained t-value is smaller than this critical t-value. So which means that we are gonna return the null hypothesis. Okay, so what's the conceptual meaning of this comparison? That is, given a kind of a distribution, the likelihood of obtaining such a t-score as large as 0.44 is very likely. So we are going to return the null hypothesis, which is there is no difference between this ice elevated data set and also the ice level data set. Okay, so the difference is actually 0. Back to our kind of put it back to our example, we say that okay, the eye level does not make any difference in perceived move size. There is no difference, so which means that this difference is actually 0, which further means that this ice elevated data set is not significantly different from the data set of this ice level. Okay, so that is the answer for this practice. I hope you guys enjoyed it, and I hope you guys got it right. That's a recap for this related t-test. We are gonna begin talking about the independent t-test for today's class.